Okay, so this is a piece of AUPT, and ordinarily I would say that those are phenocrysts of maybe labradorite or something. They kind of glow blue occasionally, right? And they've got planes of cleavage. That's what makes them do that. Maybe it makes them light up. I don't know. So anyway, I've got this one here, and I'm gonna take some pictures of it and try to make some scratches on it, because it's right there by, by by the corner, and we can kind of keep track of it a little bit. Kind of goes across into the bottom part of the stone. It's like a little slot right there. So easy to keep track of. Hang on. Okay, so I used the tip of my little diamond here. It's got a real nice sharp point. You can kind of see where I scraped it, but it's got nice sharp points. Bum, bum, bum. So there's my scrape across the place, and there it is. You see the slot. Okay. I need to clean it off a little bit, and we'll take a look. Okay. Okay, where my thumbnail is where I did that scrape. There's the little slot thing, and this right here, right, this little place to the upper left is right where the hair comes off. Yeah. Okay. That's where I made the scratch, and it's not really like labradorite at all, is it? No. It's not. It's planes of cleavage. Let's see if I can hold it real nice and still. But that's all it is. It's just planes of cleavage. And a metal, right? That's what this is. It's AUPT. Gold, platinum, alloy. And I tried to scratch it with a diamond, and I can't scratch it with a diamond. Okay, I know, everybody says, oh no, that's a quartz. Well, no, it's not. It may be silicon carbide, but it's definitely not quartz. Okay, first of all, it's very high temperature, and secondly, it's 10 on the Mohs scale of hardness. Thirdly, it's certainly not hexagonal in any way, shape, or form. It's got 6 sides, but that doesn't mean that it's hexagonal, right? Hexagonal is different than just 6 sides. It's a symmetry that has one long axis like this, kind of, except this one goes this way. But the long axis, and 2 even axes perpendicular to it. So let's look for that. There's the line, and we've got an axis going across there, and an axis going across the other way, and they're not perpendicular. I mean, they're perpendicular to each other. But they're not perpendicular to anything other than Okay, let me show you what this really is right here. See where that little diamond is? That diamond shape? That's the z-axis. They don't all have that diamond shape, just this one. Um, Usually it's just a point along where the termination is. But it shows you the corners of the box. Do you see what I mean? If I took the diamond out and just completed those four lines, it would give you like a corner of a box. And that's because it's cubic symmetry. And this axis is the same as this axis is the same as this axis, and even though these are all kind of intergrown together. And on diamonds, you'll almost always find one of these terminations will have like a dished out place, a hopper, because they are face-centered cubic hexagonal symmetry. Cubic hexagonal, the same thing. It's 6 sides from one direction and 4 sides from another. And it's the same bunch of atoms, just depending 90 degrees out of phase with each other. Okay, that's the math right there. It's 90 degrees out of phase. Bump, 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 bump. And it's not hexagonal at all. It's just got 6 sides. And the criteria on those 6 sides is, I don't know. I haven't figured it out, man. They come in about 10 bazillion different shapes. Quartz can't do that. Quartz cannot do that because it's made out of silicon dioxide that joins together, or those oxygens join together around the silica atom, 4 of them, in a double covalent bond. Okay, the oxygen and silicon share a couple of atoms with each other. I mean, a couple of electrons with each other. And that's the strongest kind of bond you can get. When you try to separate an oxygen from a silicon atom, it's almost impossible to do. Okay, they're very strong. Silicon dioxide, or they should be anyway. If I had any, I'd let you know, but I have a hard time finding it. These are 10 on the Mohs scale of hardness. They will scratch a ruby or a sapphire, and I don't think that, I know that. I have scratched many, and I have many of both, of all 3. Many, many, many. And also this is forming with spodumene. Okay? It's a lithium aluminosilicate, and lithium. This is what they use. The spodumene stuff is what they used in the hydrogen bombs to make the curtain wall around separated the combustion chamber where they initiated fission and a fission type chain reaction in uranium. This contained the explosion and forced it back in on itself. And as it carried outwards into the plutonium, carried that tremendous heat, and it began fusing. See, lithium is 3 protons, 2 protons from a helium atom and one from a hydrogen atom. And they fuse together, and it becomes lithium. It's the first of the alkaline metals. And our body uses it in its thinking processes. Okay? That's very important. And it's also very high temperature. Right? High temperature, like up there around 3,000 degrees Celsius, as are these. These come out of the mix between 3,800 and 3,500 degrees Celsius. I can take a torch to this and it just kind of gets warm. I can take a big torch to this and it just kind of gets warm. Because it's so compressed, so dense. It's a superconductor for heat. Right? This big old crystal here weighs just about nothing. Right? Lithium's the one of the lightest elements in the periodic table, and carbon's just up the road from it. It's actually two lithiums put together. You are looking at dilithium crystals. That's what carbon is. How about that? And, you know what? It really is carbon. And they really are 10 on the Mohs scale of hardness, and I actually do know what I'm doing. Right? Because that right there should scratch just about anything. It would scratch a ruby or a sapphire, which is the second hardest mineral on planet Earth. Diamond will scratch anything except AUPT. How about that? Isn't that cool? Because see what this is, this stuff is it's just carbon, right? Or silicon dioxide or silicon carbide with AUPT in the interstitial sites or planes of cleavage, and that's what gives it its color and its shininess. But I think it's silicon carbide. That's what I think it is, because it's so light. It doesn't weigh anything. You know what? Silicon dioxide is heavy, like glass. You pick up a piece of glass. It's cold to the touch, and it doesn't warm up or anything. This is body temperature, just as soon as I pick it up, just like a diamond, because it has double covalent bonds. And those double covalent bonds are what make it so shiny and scratch free, right? Because you cannot scratch it. Doesn't matter what you try to scratch it with, you cannot scratch it. Okay, so if I drill a hole through here and I mount a propeller shaft in there, for instance, or for a little plane or something, and I get the thing going around and around, it won't wear out. It's light. It's like light, like plastic. It's that light. It's lighter than aluminum, huh? Because it is carbon, right? It's carbon. It's just carbon. Or carbon and silica. Silica is in the same family as carbon. They both have 4 electrons in the outer valence orbit, and that means that they can share those 4 electrons with each other to create the double-double covalent bond. And only silicon and carbon can do that. It takes too much energy for silicon to do it by itself. It can't do it by itself. There's no silicon atoms, but there's definitely carbon molecules, and you know what those are there? Maybe diamonds inside of silicon carbide. That's what that shiny stuff is. You know how I figure this stuff out? A little bit at a time. Because I gotta work through it myself. Right? I don't know anything, man. I didn't read this stuff in a book because nobody else knows this stuff. It's original research. And I do it by measuring things. I can measure with my camera. My camera has excellent vision, and I can measure the light being reflected, or I can measure the emissions of radioactive elements with my camera. And I can see details that other people don't see. A whole lot of them. Not because I'm anything other than a photographer. And I take pictures of everything.